Welcome to Curie Electronics. In this video, we are going to learn about voltage divider or potential divider. In electronics circuits, we often come across voltage divider circuits. We have a battery here, voltage source V, and R1, R2, and we have to find what is the voltage here, what is the V out here. V out is across R2. The same circuit we can, this is a simple way of drawing the voltage divider, but when it gets into little more complexity, we can draw it as this is going to be a VCC or voltage source or V in. These are going to be two resistors R1, R2. So this is a series circuit. So in series circuit, we know the current is going to be same current flows through R1 and R2. Let us take another diagram. Let me draw it. We have two resistors and I am giving a V in of or VCC. I'll write it VCC. VCC equal to 10 volt. And my first R1 resistor equal to 10 kilo ohms and R2 equal to 10 kilo ohms. And what is the V out here? This means we will write this is the V2 because it is across R2. What is the V2 voltage? If you carefully look at these resistors, both the resistor values are same. So as per KVL, whatever the V in, this 10 volt should be dropped across to these two resistors. That is, so we can write 10 volt. As per KVL, the applied voltage should be equal to the voltage drops across the resistors. And then in this circuit, the resistors are of equal value. Then V1, what is V1? V1 has to be 5 volt, but because it is getting equally dropped across the resistor, V2 equal to 5. Then we will get sum of 10 volt. The same circuit, if we change the resistor values, then what happens? Only the current changes, but we are not getting into details of the current. So here this is R1, R2, and here we are giving 10 volt, little bit 1 kilo ohm, this also 1 kilo ohm. Now what is the voltage across R1 and R2? Now already you know what is the voltage across. This is going to be 5 volt because equally it is getting divided. Here also it is going to be 5 volt across R1. Let's see one more. So we have one more resistor here. This is 10 volt. We have a 5 kilo ohm resistor here. Let's not take equal values. Let's take a 6 kilo ohm resistor here and here 4 kilo ohm resistor here. This is not so easy to find. We need some equation. So that later we'll see. This is actually in the proportion of this is in the proportion of 6:4. If we see carefully, if you observe this 6:4, this can be written as 3:2. That means if 6 volt is going to drop here, then what we are going to get? Here we are going to get 4 volt. It is in the ratio of, the 10 volt is getting divided in the ratio of 6:4. So finally, next what we will do, we will learn a direct equation to solve this, because when the voltage values are when voltage values changes or resistance changes, it becomes little difficult to take this proportional, to apply this proportional logic. Anyway, one more, this finally we'll check it. Before that, let me draw one more proportional logic. That is, we have 10 volt VCC, then we have a 8 kilo ohm resistor and 2 kilo ohm resistor. Now what is the voltage drop across 8 kilo ohm resistor? VCC equal to 10 volt. Then now usually you will say it is in the ratio of 8:2. So here 8 volt is going to drop here, remaining 2 volt has to be here. Okay, now what happens when it is the values are the 10 volt and all, we can easily manipulate. If it is 4.2, 4.5, what we do? For that we have a direct equation. That is, I will write it here. We have a resistor divider network. So we are going to see for 2 resistors. This is VCC is the supply. This is R1, R2. Voltage drop across R1 equal to V1, voltage drop across R2 equal to V2. Now there is an equation. If I want to know V2 equals to R2 upon sum of the 2 resistors, that is R1 multiplied by R2 multiplied by the VCC or Vin. This is the direct equation. By applying this direct equation, we can find the value of V2. Similarly, if you want to find the value of V1, what we write? V1 also. Similarly, we can write V1 also. V1 equal to R1 upon sum of the 2 resistors. Remaining everything is same. That is R1 plus R2 multiplied by VCC. So using this equation, we can directly apply the values and find out the voltage drop. Now let's try to derive this equation. So we are trying to derive that equation. How to derive it? We'll derive it for either V2 or V1. Let's take V2 only here. This is R1, R2, and voltage drop across R1 is V1, voltage drop across R2 equal to V2. We have to find the equation for V2. We already know, but let's try to derive it. Now as per KVL, what is VCC? VCC equals voltage drop, sum of voltage, that is V1 plus V2. Now, so VCC, this is a series circuit, so we can write what is V1? I R1. Because same current, same I is flowing through both the resistors. I R2. Now what we need? We need V2. So same equation we will write it as VCC. Now let's get I from here. We will find the I. I equals, what is I? VCC upon R1 plus R2. We have taken I as the common and took to the left side. So I equal to VCC. This is our equation number. One number you can give it. Let it be 2. I. Now which is our equation number 1? Let's just take it as equation number 1. So what we'll write, next we'll write VCC equal to V2 we want. So what is V1? V1 we know I multiplied by, now we don't want I because I we have. What is our I? I is VCC upon R1 plus R2 multiplied by R1. For I we have put VCC upon R1 plus R2 plus V2. Now what we need? We need V2. So V2 equals VCC minus VCC R1 upon what is there? R1 plus R2. Now what you do? You have to simplify by taking the LCM. So V2 equals, I'll write the LCM, that is R1 plus R2. Then we are multiplying the numerator, multiplying the whole term by LCM. That is VCC multiplied by R1 plus R2, R1 plus R2 minus VCC R1. R1 plus R2 get cancelled there. So V2 equals, let's open the bracket, VCC R1 plus VCC R2 minus VCC R1 upon R1 plus R2. Now what happens? So here VCC R1 will get cancelled. So V2 equals VCC, let's write it in a, first I will write R2 here. R2 upon R1 plus R2 multiplied by VCC, that is the whatever the input to the voltage divider circuit. So we have derived the same equation which I have wrote some time back. So similarly you can derive this V1 also we can derive. So you got the idea of potential divider. Now let's see what if there are more than two resistors. Let's take one example for that. One resistor, second resistor, third resistor. We have four resistors connected in series. And what is the supply voltage? Supply voltage is 24 volt. That is VCC equal to 24 volt. First resistor is 10 kilo ohm. And second resistor is 7.5 kilo ohm. Third resistor 1.5 kilo ohms. The last resistor is 1 kilo ohm. Now 24 volt has to be dropped across all these resistors. Now what is the logic we can apply here? Now we want to know what is the voltage drop across 1 kilo ohm resistor. What is V here? Then what we do? We will consider these resistors as two resistors, that is 1 kilo ohm and the sum of the remaining resistors. So 10 kilo ohm plus 7.5 kilo ohm plus 1.5 kilo ohm. So 17.5, 18, 19 kilo ohm. So we will take R1 equal to 19 kilo ohms and R2 equal to 1 kilo ohm. Now we will apply the same equation. So V equals 1 kilo ohm 1. We'll just put 1 only. 1 upon 1 plus 19 multiplied by what is VCC? 24 volt. So V equals what we get? 1 upon 20 multiplied by 24. So what do we get? If you divide both by 4, 6 times, 5 times. So we will get 6 upon 5 volt. That is 1.2 volt you get. Similarly, this is the last case we are considering. If you want to find a drop across 1.5 volt, now here at this point what is V? Then I'll write V equals. So first to this, my R2 is going to be sum of 1.5 plus 1.5 kilo ohm plus 1 kilo ohm. So I'll get 2.5 kilo ohms. And what is R1? R1 is going to be, R1 equals to what? Let me erase it. R1. What is R1? R1 equal to sum of 10 kilo ohm plus 7.5 kilo ohm plus that's it. Only two resistors. So it is going to be 17.5 kilo ohm. 17.5 kilo ohm. Now we apply the voltage divider rule. So V equals R2 upon sum of R1 plus sum of two resistors, R1 plus R2 multiplied by VCC. So V equals, what is R2 we have? We have 2.5 upon, what is R1 plus R2? We have 17.5 multiplied by 24. So what do you get? If you divide 2.5 4 times, it is 10. 1 by 7 into 24. So 24 upon 7. What do you get? 24 upon 7. 3 sevens are 21. So we will get around 3.4 volt. 3 point something we will get. Around 3.4 volt. 21, remainder 3. Yeah, almost 3.4 volt we will get. So this is how we have to find the voltage drop across resistors. I hope you understood the concept, and this kind of circuits we come across regularly in electronics. So if you like the video, please share with your friends and don't forget to hit the like button. Thanks for watching.